Assalamualaikum and hi everyone, especially to my panel, Encik Muhammad Faiz bin Wahid and Dr. Hambali bin Boenjang. My name is Muhammad Fikri bin Roslan and today I will present my final year project 1 entitled Investigation on Physical Properties of Fiber Fillet Composite 3D Printing Part. This project is supervised by Dr. MASTURA binti MOHAMMAD TAHA. For the chapter 1, I will brief about background, problem statement, objective and scope of research. Additive manufacturing or 3D printing is the process creating a three-dimensional object from CAD model. 3D printing can refer to a range of procedures in which material is deposited, fused or solidified under computer control to create 3D objects with material such as polymer, power grain or liquid being added layer by layer. In 1980, 3D printing techniques were considered suitable many types of production, but rapid prototype were considered more appropriate. In 2019, 3D printing accuracy, repeatability, and material range have increased to the point that some 3D printing techniques are now considered acceptable as an industrial manufacturing or production technology. One of the most appealing features of 3D printing is its capacity to make complex shape or geometry that would be difficult to achieve by hand, such as hollow piece or part with an internal thrust system to reduce weight. 3D printing filament is thermoplastic feedstock for 3D printer that use fused deposition modeling. There are many kinds of filament available with its own variety of properties and printing temperature. 3D printing filament is produced by heating, extruding and cooling plastic process to convert noodle into complete product. The extruder temperature can be modified to meet the melting point of a specific filament, and most commercially available desktop printer can reach temperature of 280 degrees Celsius. Biocomposite, which combine natural fiber as a reinforcing element with a biodegradable matrix, are a friendly environment product made from natural resource that has a long useful life and is totally biodegradable after use. They are less hazardous, simple to manufacture, have a high strength to weight ratio, and can help reduce carbon emission. For this reason, biofiber reinforced polymer have seen remarkable expansion in recent decades, particularly in the food and medical packaging industry. Natural fiber reinforced composites are biodegradable and recyclable and will eventually replace petroleum-based polymer composite. For the problem statement, the fiber in the filament make the surface of the object rough during FDM process. Second, dimensional object of 3D printed part in CAD and actual object after print. Third, additive manufacturing with affect physical quality of 3D printed part when we improve the parameter of FDM. The main drawback of additive manufacturing technology are due to the fact that nozzle temperature fluctuation during the printing work could lead to high surface roughness and warping. Surface finish quality not only for the better functionality and appearance, but also for cost reduction regarding reduced post-processing of 3D printed part and overall prototyping time reduction also. Many fabrication parameters have impact on the surface quality of FDM 3D printed part. For example, layer height, nozzle diameter, printing speed, plaster angles, shell thickness, and infill density, and so on. Moreover, different factors make diverse influence on the surface quality and dimensional accuracy of the printed part. For the main objective of this research are, first, to investigate about surface roughness, dimension accuracy, and physical quality of fiber fillet composite using fused deposition modeling. And the second is to analyze the correlation between physical properties and printing parameter. For the scope of research, FDM 3D printing are used to investigate physical properties of fiber fillet composite. After that, we need to print temperature tower for each material to get most accurate of nozzle temperature before we print the 3D printed part. And the last, we will collect data from each material to analyze and compare the surface roughness, dimensional accuracy, and physical quality of the 3D printing part. The content at the chapter 2 will obtain about 3D printing, fuse deposition modeling, and the material. Additive manufacturing is a term for the process of building three-dimensional objects by slapping different kinds of material on top of digital model. Computer-aided design is used to produce a 3D model of the product. Then, the 3D model will be saved in standard translation language or STL file. STL file, which can read by 3D printer, is then generated from model by slicing it horizontally. The data is then delivered to the printer for printing, and the printing parameters are then set up to print the material. Today, rapid prototyping is being across numerous industries, including in medical, manufacturing, architecture, aerospace, automotive, and food industry, as well as in fashion design and education. For example, the application of 3D printing in medical continues to grow, both in volume and diversity of application. 3D printing has primarily been utilized for the creation of anatomical model and surgical guidance. The use of 3D printed part in aeroplane has potential to save considerable amount of energy and fuel due to their reduced weight. Furthermore, 3D printing also has been routinely employed to print spare parts for variety of aerospace components. 3D printing also utilized in automotive industry to generate lightweight car part, component replacement, spare part, and prototype on the assembly line. The company may test a number of options and prioritize them early on the development process with usage of 3D printing technology in automobile sector. 3D printing also has potential in food industries. Low cost, high efficiency food production with good quality control and environment advantage is now possible with 3D printing. Fuse deposition modeling is the process which 3D object was created by layering thermoplastic filament that has been heated to the melting point. 3D printer used for FDM include a support base with certain degrees of freedom and configuration that allow it to move in a vertical direction. An associate extruder is attached to the bottom plate and is able to connect the filament, heating it to the melting point, and then extruding it layer by layer with the assist of nozzle to make the needed product. The extruder is capable of moving in all three directions, X, Y, and Z. A computer-aided manufacturing software program running on a microcontroller, the mechanism, which can move in both horizontal and vertical direction. The filaments are made of variety of thermoplastic. PLA is a commonly used thermoplastic in FDM printer. It's becoming popular because PLA is a biodegradable thermoplastic. It also producing high quality of prototype and operational part also use less energy and heat. PLA material also has higher tensile strength, lower weight, and less ductility. The table has shown the properties of the PLA. Natural fiber were divided into three categories, which is animal, plant, and mineral. Plant fiber are the most used fiber in manufacturing industry for a variety of applications. Natural fiber are readily accessible, inexpensive, and can be produced indefinitely using only non-pollution resource. Natural fiber can offer many advantages including lightweight, biodegradable, easy to maintainability, non-toxic, availability, and low cost. Natural fiber can be collected from a variety of sources including stem, leaf, and seed. It can be classified based on the plant part from which they are taken, such as stem fiber, leaf-based fiber, seed-based fiber, fruit-based fiber, stalk-based fiber, grass-based fiber, and wood-based fiber. Wood fiber are usually cellulosic elements that are extracted from trees and used to make materials such as filament of FDM 3D printer. Hardwood obtained from the deciduous tree, and softwood is collected from conifer tree. Basically, hardwood is heavier than softwood. Early wood filament were made with sawdust. Wood fiber used to make filament which is composed of around 70% PLA and 30% wood fiber. The advantage was its greater flexibility and 3D printed object can look like carved wood. Knaf fiber is the bast family which is selected due to its high strength. The properties of knaf fiber caused by its chemical composition, cellulose, hemicellulose, and lignin constituents. Knaf fiber, the most well-known plant fiber used for reinforcement in polymer composite. In Malaysia, the knaf plant was selected due to its fast growth rate, superior reinforcement properties, and high photosynthesis rate. It provides strength reinforcement for PLA polymer composite and create composite product low in cost and weight. Knaf plants are environmentally friendly not only due to their biodegradability but also because they release more oxygen and reduce carbon dioxide than other plantations. Based on classification of natural fiber, sugar palm fiber being relatively new when compared with other natural fiber. The fiber from sugar palm tree can come from either bunch, frond, or trunk. The starch from the sugar palm trunk can be utilized as a biopolymer, which can be used with natural fiber to produce a biocomposite. The use of starch as a biopolymer will greatly reduce dependency on petroleum-based polymer. The trunk of sugar palm tree is completely covered with black fiber. The early application of the fiber include paintbrush, broom, rope, rafting material, and many more. For the chapter 3, I will explain about the methodology. The slides show the process flowchart of methodology. First, we need to select the material used, which is PLA wood fiber, PLA knaf fiber, and PLA sugar palm fiber. Then we need to prepare the sample. After that, we need to design the temperature tower and Lego brick in 3D model using SolidWorks. The process we use in FDM 3D printing that we will print out the temperature tower to identify the best temperature for each part using filament material that we select. After get the best temperature, we will print out the 3D printed part specimen. And lastly, we will analyze the data about surface roughness, dimensional accuracy, and physical quality of the 3D printed part. In 3D modeling, we use SolidWorks software to drawing the temperature tower and Lego brick. The drawing will save in STL file that used to store 3D CAD model. The STL file then was imported into the Ultimate Calculator software, which is used to slice the model. The STL file is converted into layer in the slicing software Ultimate Calculator, which then generate the tool path to fill them and decide the quality of the filament to be used in the product manufacture. The code files are generated for each layer of the product, and this code offers instruction for the tool X, Y, and Z motion to generate the appropriate layer. The filament material used in this research was PLA wood, PLA knaf, and PLA sugar palm. These three filament material will print out using FDM 3D printer with the different and suitable parameter. For the inspect in surface roughness, sample will be identified with various parameter value. A contact typing surface testing, scanning electron microscopy, Fourier transform infrared spectroscopy will use to identify the surface roughness of specimen. When it comes to working part, dimensional accuracy is crucial. One of the component accuracy requirement was the minimum difference between the manufactured part dimension and the CAD model dimension. Each axis was examined separately to determine the deviation. The dimension will measure with micrometer or digital vernier caliper. For the expected result, we hope we can get a suitable parameter of the filament material to improve the surface roughness and the dimensional accuracy of the specimen. Besides, we also hope that we can determine the suitable parameter of PLA sugar palm because this filament has lack of research about it. And the last, we can find or investigate the suitable application of this filament for the future use. That's all from me. Thank you.